Probably, you may not believe that I was very shy person. My name is Kota OHASHI. I was not good at speaking in public like this. I was not good at talking to people for the first time. I was not good at raising my hand in the class since I was schoolboy. But one thing changed this my weak point dramatically. It is a study abroad program. When I was sophomore, I went to University of California, Davis as a study abroad program. This experience made my view broaden dramatically. I found it fun to talk with foreign people and I learned the importance of being active through homestay and interaction with American people. After this program, I took part in another program. In this September, I went to India for about 10 days. I was very surprised at the difference between United States and India in terms of people, culture, and so on. In this program, we thought about several problems which India faces on today, such as transportation, healthcare, energy, and so on. Look at this! Passengers are getting out of the bus while running. I have never seen this situation in Japan. One of this kind of problem, I worried about water resources problem in India. According to World Health Organization, about 97 million Indians cannot get access to drink safe water. In addition to that, about 1.5 million children die of diarrhea per 1 year. I thought I'd like to give safe water to India. I'd like to see their smiles. I'd like to be useful to India as a chemist. Today, I'll show you the great technology of water purification by photocatalysts. At first, I must explain what catalyst is. Catalyst is a substance that initiates or accelerates a chemical reaction without itself being affected. Photocatalyst is a kind of catalyst, especially using light. In short, catalyst helps to change one molecule to another molecule. Therefore, catalyst is used a lot in many chemical reactions. Studying abroad is not a chemical reaction, but I can say it is a catalyst for me in terms of changing my mind. Most of cases, people use titanium dioxide as photocatalyst. It is based on its cheapness, stability, oxidation reduction power. Well, how is the mechanism? This figure shows the state of electrons in titanium dioxide. Usually, electrons are in the valence band colored by blue. There is an energy gap between valence band and conduction band colored by purple. It is called band gap. In case of titanium dioxide, the band gap is about 3.2 electron volt and this energy is equivalent to ultraviolet rays. When light shines on photocatalyst, electron is excited to conduction band and electron hole is generated. Electron hole and electron causes a chemical reactions and it produces hydroxyl radical and superoxide anion. These two chemical substances have a large reactivity, so they are capable of decomposing organic matters. Nowadays, photocatalyst is used a lot in several fields. Look at this video. This is a self-cleaning technology. Only by shining ultraviolet rays, it is possible to remove dirt. Of course, self-cleaning technology is very nice, but what I'd like to say in this presentation is water purification by photocatalysts like this movie. As I said before, the mechanism is like this animation. Researchers already make self-cleaning technology practicable, but water purification is not yet. It is because of diffusion coefficient. This number shows the tendency to spread. It means the larger this number is, the easier chemical substance spread. the number in the liquid phase is much less than in the gas phase. That's why water purification has not put into use yet. Well, why did I focus on photocatalysts? In regard to water purification, there are some conventional methods. But these systems have some problems such as health, energy, and cost. The biggest merit of using photocatalyst is its driving force. As long as the sun rises, we can use photocatalyst. In addition to that, quantity of solar radiation is relatively high in India. India also faces an energy problem, so I think this method is very energy saving. Today, there are mainly two kinds of systems about water purification by photocatalyst. The first one is disperse system. The mechanism is to put particulate titanium dioxide into reaction liquid. This system is efficient because of the large surface area, but it is necessary to collect minute particles. The second one is fixed system. The mechanism is to put titanium dioxide film fixed on substrate into reaction liquid. In this system, people don't have to collect photocatalyst, but the efficiency is less compared with dispersed system. In order to solve this kind of problem, Panasonic developed new technology recently. It is a photocatalyst attached to zeolite. When people put this photocatalyst into reaction liquid and stir, these minute particles spread in the water. And when people stop stirring, these minute particles recombined with zeolite because of electrostatic interaction. In this way, it is not necessary to collect minute particles, and the efficiency is very good in this system. Another problem is about light. As I said before, titanium dioxide absorbs only ultraviolet rays. Figure 1 shows the sunlight spectrum. It is said that ultraviolet rays account for from 3 to 5% of sunlight. As you can see this figure, sunlight has large intensity of light in visible light region. So, researcher is developing new type of titanium dioxide which is capable of absorbing visible light. As one of solutions, researchers introduce nitrogen dope. Like this animation, when people replace oxygen atom with nitrogen atom, band gap becomes smaller. Visible light has smaller energy than that of ultraviolet rays. So, nitrogen-doped titanium dioxide is capable of absorbing visible light. As I mentioned before, there are some challenges in regard to water purification by photocatalysts. But I believe that light makes world brighter in the near future. And I want to be catalyst for water purification in India in the future. Thank you for listening.